today's coffee session is a little different, isn't it? We've got 4 of the engineering lab participants with us today, and they're going to talk us through their experience of the engineering labs. They're going to talk us through what they've learned, what they liked, what they didn't like about the engineering labs themselves, and also about the actual tools that we had them using. So there's a few things that we should probably mention before we even start. Like, what are the engineering labs? I think is a great place to start and figure out what exactly did we have you all doing. And I will say that although I am interviewing this crew today, we've got the team of 4, John, Alexey, Varun, and Michel or Michael. Is it Michel or Michael?
Michel.
All right, Michel. There we go. So, although I am the one interviewing them, I was not the lead on this project. I cannot take a lot of the credit because that goes to Ivan, who is not with us, but you've probably seen him around Slack, aka Ilnardo, and he's the one that organized it. He's the brains behind it. And so we got to give credit where credit is due. Now, let's talk about the engineering labs and what they are real fast before we jump into some questions. The engineering labs are a series of voyages. We just finished the first one, but the vision for engineering labs is like Kaggle, but for MLOps. That is the idea here. We want to create a session or series of sessions or competitions even where people can get together, they create teams, and they create products around the infrastructure of machine learning. So with that, you get to use and get your hands on different tools. You get to try and architect your own ways of doing things. And so the first one was, since it was our first time, we had it very open-ended, and I'm sure the guys are going to tell us all about how it was too open-ended. But we just said the only requirements are that you need to use MLFlow and Pytorch. That was the requirement. And so now I think we are done with it. We had some incredible results. And this is Team 1, very original team name, by the way. We have Team 1 coming at us today, and they're going to show us or tell us about the results and tell us about how they found the whole process. And so that we know, there were 4 teams that were started and only 2 of them finished. So Team 1, you guys did a great job in finishing. First of all, huge credit to you for that one. But then what you did, you didn't just finish, you went above and beyond. And what we can see with your products that you created and how you created them, it was really exciting for Ivan and I to just watch you create. Well, over the span of, I think it was almost 8 weeks, was it? Or 6 weeks? I don't know the exact amount of time that we gave you, but you did it very quickly. It was just before the holidays, maybe, that we started. And then by February 1st was when you had everything done. So let's jump into it. I mean, I think it's worth just talking for a minute about probably the first question, and the best thing that we can do is explain to people your name, where you're working, how much experience did you have before this? And John, since you're to the right of me on the screen, I'm going to ask you to go first, and then you can pass it off to the next person when you're done.
Hi, I'm John Savage. I'm a machine learning scientist at Overstock. I'm living in the west coast of Ireland, but Overstock is based in Utah. So they have a pretty solid MLOps setup without it being MLOps, if you know what I mean. They've got a lot of really, really solid engineers on the team. So they've built out a great operations for ML before this became a thing. So by osmosis of being there the last year, I've kind of picked up a few best practices. So that was my kind of general experience. But no experience with MLFlow or no experience with these types of open source tools.
Nice. And did you want to like did you want to learn about MLFlow before this?
Yeah, because like again, the guys have built out tools like a model registry and deployment pipelines, but I wanted to take a look at an open source one and see was there anything that we could take inspiration for in our tools,
Nice.
or even, you know, if it's good enough, should we replace our internal tools with these open source tools? Does it make sense?
Cool. Yeah, for sure. All right. I've got Alexey on the screen to the right. Alexey, you want to let us know who you are, what you're doing, where you're from, and how experienced were you in this?
Sure. Hi, everyone. My name is Alexey, and I am software engineer at an ML platform startup. And as I said, I am a software engineer. I have never worked with an ML model. At our company, I work more on the infrastructure side. So I'm creating tools that ML engineers or MLOps engineers use, some frameworks, pipeline tooling, and so on. And I saw this engineering lab as an opportunity for me to actually to see how these tools interact, how real work is being done by people who actually train models and run inferences on them and stuff like that. So for me, all of this was completely new. And we, in our company, we do experiment with MLFlow a little bit in some of our demos, but we don't use it in production. So I was interested in seeing how it integrates with other things, with Pytorch in particular. Yeah, it was a great experience for me to see, and actually not only to see, but to have hands-on experience with the whole pipeline.
Excellent. So I've got Varun on the next screen over. Give us a little bit about yourself.
Hi, I'm Varuna. I was a mobile and web developer, and for the last 2 years, I've been studying deep learning. So I was kind of familiar with Pytorch. I looked at MLFlow a couple of times for different reasons, but I had never used it. The whole ops thing was new to me.
Excellent, man. So now last one,
And
Michel.
Varuna's being what's the word? Humble, because he's got a tool called LabML that's really great for looking at tracking. So I think it fits really well with the discussion. If we're talking about like how do we track experiments, I think LabML is a cool tool. So he should talk about that.
Yeah, let's get into that in a little bit, because we definitely need to talk about all of the different things that you all found out about each other and tools and everything. So before we jump into that, Michel, can you give us?
Okay, hi guys. My name is Michel, and I live in Fortaleza. It's northeast of Brazil here. It's a pretty cool place to live. Okay, it's nice here, sunny every day. You should come here during your vacations. And I'm a software engineering guy. I work at public banking sector, and it's been a long time I work there. It's the place here is Banco do Nordeste. It's a development bank, and I don't know if any of you guys have worked in a bank before. They are really, strict with things, and I lead a team there. The main concern of this team is system and software engineering. System and software architecture. And I have low experience, I can say, with machine learning. I joined the community because I'm a PhD. I'm a PhD student as well at Universidade de Fortaleza. And my main concern in my PhD is joining software engineering and machine learning. And that's why I'm joining the community. And I love this. I love it. The whole thing I found there, engineering lab, is a cool initiative. It was really nice, and I guess we're going to discuss a little bit about this here.
Excellent. So I think the first thing that we should probably talk about is what did the process look like for you all? Because Ivan and I just set you loose. We said, do something with Pytorch and MLFlow, and then we let you figure out the rest. So maybe it's worth just talking for a minute about how the first steps were. Like, how did you decide what you wanted to do? And then how did you get started along that? And also let us know what eventually you created. And so I imagine everybody is not going to want to talk twice. So I see Alexey to the right of me. I'm going to go ahead and pass it off to you. Give us a little bit of info.
Sure. As you said, there was no directions. Initially, we just were added to a Slack chat room. For me, that was a very new experience. I've never worked in an environment where there are few engineers who don't know each other, with no explicit leadership, with no directions, like with nothing. It's just a room with 4 engineers or, well, specialists. So I think that John implicitly took the leadership and held it over the course of the whole project when he suggested us to have I think that was John, but I might be mistaken, who suggested us to schedule a Zoom conference, and then he was kind of leading the discussion in general. But on our first call, we came up with several ideas, and we discussed a few options. What models can we work on? What aspects of MLFlow and Pytorch integration can be considered, and what is feasible given our time frame? After a relatively short discussion, we decided that we've got enough interest in NLP in general, and there was an example project in MLFlow repository for a news classification. So where you would your model would tell whether a news excerpt, some news snippet, belongs to one of certain categories, such as business or entertainment or something else. So we thought that this model, which is already exists, can become a product over the course of the lab.
That's excellent. Yeah, and so you all know, for the next one, we're trying to do something for. We're going to have it be more specific, because I know that was a big thing for most people. They were saying, well, we didn't know what to do, and then we got caught up, and a lot of people couldn't get past this first step, which was just to decide, what are we going to do, how are we going to do it, and what's the reason for it. So basically, what's the problem that we're solving? And it seems like you all figured that out quite quickly. Then you went out and you started implementing it. And what did the implementation look like? And John, maybe you can give us an idea of how you went about structuring it and then coding it.
Yeah, I think once we decided on that project, at least to get us going with, and we thought we can always cycle back and swap that out with something else later if we get to the point that it's all done. But once we had decided that, we kind of talked among each other, what did we really want to learn and discover through it all? And everyone was mostly focused on the MLFlow part and the deployment part. So big things that people wanted to do were automation, Dockerization, and really getting something into the cloud, deployed onto the cloud. So they were probably the 3 major things that we wanted to learn off the back of doing this, on top of just doing MLFlow and Torchserve. So once we had kind of got an idea of those were some things that we wanted to tackle, we talked about we kind of went away, we did a bit of messing around, we got familiar with MLFlow, we got familiar with Torchserve, we got familiar with that project, let's say, and then we came back and talked again and we talked about what's the architecture going to look like and what are the workflows that we can work on in those on that architecture. So we can dig into that someone else might want to take that on. But once we had that kind of idea of like, okay, here's an architecture and here's some workflows we think we might want to work on, like let's say training and deployment. I think what was unbelievable was that Michel went off that week and made this diagram that showed exactly what we've been talking about. And in my mind, I had a vague sense of the architecture and a very vague sense of the workflows. But once that diagram was in place, like it all started clicking into place for me. I could see the bits like, okay, we might need to change this or change that. But once that was all there in front of us, we could it was much easier to go ahead and code something. And then it was much easier when we did run into a couple of issues down the line, we're able to kind of all speak about it in the same language, like, okay, the train server isn't doing what we needed to do or whatever it was. We all had that common language to be able to discuss things. So that was, I think that was a real turning point. That was like what made it a success is having that early and having it decided early and being able to always refer back to that at all stages.
So you took a stance and you said, all right, this is where we're going to go. You became a bit opinionated about it. And I think one thing that is probably for me the most spectacular piece of this whole engineering labs is that what you're talking about, John. And it's Michel, you decided to go and draft up this diagram which shows very, very clearly what the goal is. So can you talk us through a little bit about how you did that? First of all, how you knew to do that, and then did you encounter problems along the way? Because I know, okay, so if anyone hasn't seen the diagram, we'll put a link to it in the show notes so that you can go check it out, and definitely go look at the GitHub right now because it's amazing. And it's very easy to draw a diagram and just say like, oh, we're going to link up this and we're going to link up that. But the amount of you specified so much in that diagram that it's very hard to make a left turn, right? Or go off track. So maybe you could walk us through that, Michel.
Oh, yes. It was really nice to do that. And the main thing, I thought about drawing that because, one, I'm used to do that. I lead a system and software architecture team, so we do that a lot. And I have guys here that do that and do that well, so I could learn from them. And we also there are some things we don't talk about, but I think that every initiative like this, engineering labs, we have one important thing: the language challenge. I mean, we are 4 guys here. I think that John is the only one native English speaker. And sometimes I thought that I was talking something here during the meetings, and are the guys understanding me? And so I thought, okay, going to draw something, going to do some design, so we could all be in the same ground. And that's when the design came out. I really think that designing things, models like that could be valuable, really invaluable. And I think that's it. I just try to put there everything people would need to get the whole picture, For me, it was a little bit difficult because I'm much more software engineering guy, okay? So sometimes I had to touch stuff there. I went to another GitHub repos that had ML things there to understand the whole picture and try to put that stuff in the design, the picture. And I think that since I'm doing this kind of thing, I'm used with this kind of thing, how can I say that? That was made things easy to me, okay?
Yeah. So you went and you designed it. what were the first surprises that you realized, well, this isn't going to be exactly how I designed it, or this is going to be a lot harder? What were some things that jumped out? And maybe you can, Michel, you can walk us through a little bit of how it was designed, so that we have a quick overview for people who are listening and haven't looked at the design chart yet. Although they probably will go and look at the GitHub right now, but maybe you can just give us a rough overview of what you designed, and then where was the first problem that you saw?
Okay. First thing is that I never think that a design should start and finish the way. I mean, it's not something that is something that is in movement. Okay, you know what I mean? It's something that should be updated. It's a live thing. So that happened with our design. I mean, the first time we started with the design, we were thinking about a bunch of servers there. I mean, one server for training, one server for serving, one server for control everything. And in the end, we tried to remove all those things because we were trying to go more cloud native. And that was one nice thing that I saw during our work. I mean, it started with one picture and we evolved there. I mean, it was really nice to see that in a month, we started with one perspective, one baseline, and we evolved that to another that I think that's much more modern. Okay, and I think that when I started to design and to draw the workflow, I was doing that like a software engineering guy. I see every day here at my work products coming from development to production, and I try to reproduce this kind of thing there in the design. And after that, after the meetings, after talking with John, Alexey, and Varuna, I was starting to improve the thing, improve the workflow. So I can say that our discussions during the Slack meetings were really cool because I could learn a lot of the difference between traditional product and an ML component being built, developed, built, and deployed into production. I think that is
nice.
It is.
Nice. Yeah, and I mean, Varuna, I want to ask you a question real fast because coming from, I mean, I know Michel has this software engineering background and which he was relying heavily on. You're coming more from the deep learning, and I'm wondering how that whole process was for you. Like, was there a lot to catch up with, or did you feel like it was fine? Can you explain a little bit of how it was?
So I only looked at the research side of deep learning. So this was like totally new to me. The only time I deployed some sort of like did something similar was we took a existing model and tweaked it a bit to summarize articles. But for that we just ran the thing just in a Flask server. We would just run the Pytorch model and make inferences. Like we didn't use anything like Torchserve. I'm not sure if it existed back then. It was like early last year, probably. Maybe we didn't look into it, but I'm not sure. But we did it a very simple way, all ground up, nothing.
Okay.
So this was completely new to me.
Well, talk to us a little bit about this tool that you had that John was calling out. What was it called?
It's called LabML. It was called Lab. It's a. Have you come across Svandeep, like weights and biases?
Yep.
Oh, so it's similar to that. It's sort of like keeps track of all the experiments you ran, and it'll let you monitor your training as it goes on.
And this is homegrown? You built this?
Yes. So this was built way back. We've done a bunch of improvements recently.
Nice. Okay. So did you guys implement this when you were using when you went through the engineering labs?
In some of the training runs, we had it attached.
All right, nice. So I'm still looking for.
So,
Oh yeah, go ahead, Varuna. Sorry, I cut you off.
we in our architecture we sort of had all the training stuff sort of coupled apart from the rest of the things, so anybody could sort of train things. And we actually, John wanted to try like hyperparameter searches and different models, but I tried a little bit, but the BERT model was doing very well. There was nothing much to tune there, so we sort of gave that up.
Awesome. Now I'm still wondering about the 30,000 foot view, like the overview. I know we've talked a bit about this diagram and we've talked about what you ended up putting into production, right? But maybe you can walk us through how things worked, and I'll default to you, John, on this one. What exactly was it? How did this go from, basically, can you take us through the pipeline and then the serving and what the diagram, what the overall view of it is?
Yeah, sure thing. I'm just pulling up the slides from last week, so I have something to refer to.
Yeah, nice.
But yeah, so I think it was interesting that when I was doing up the presentation for Pi and AI, I was taking a look at the Google MLOps levels. And as I was looking at that, I realized we were kind of moving things from level 0 to level 1. And it's interesting that because most of the team here were software engineers, we all automatically started from the source repository. That's where our project starts. It starts at the source repository. And it kind of assumes that all of the experimentation has been done. So it's an interest as a machine learning scientist who, like, my world is mostly the experimentation part. It was interesting, like, that here everyone was like, nah, like, I don't want to see it. I want to start from, like, that work has been done. So yeah, it starts from the repo, and it assumes, like, let's say a data scientist has a new model that they want to throw into production. So then we're going to automatically train a model. Once they do a pull request, someone would review it, and then that would merge into master. That would automatically then spin up a new training session. So train a full model. That happens on a Google Cloud training server, and that's running MLFlow. So that does all of the MLFlow tracking of metrics, parameters, and then at the end logs the model artifacts. And that those model artifacts are logged to the MLFlow model registry. And so that was one of the core parts of this this project, because the announcement was the integration of Pytorch to the model registry. So logging that into the model registry in a standardized way was something that they had developed in November, or released in November last year. So then once that has been logged to the model registry, then the next step in the automated pipeline is to Dockerize that, essentially. So we build a Docker image, and as we're going through that, we start up Torchserve, we register our model, we pull it down from MLFlow, register with Torchserve, turn off Torchserve, and then set the entry point of the image to be Torchserve. So that's a fully ready to go image. As soon as you Docker run that image, it pops up ready to do inference at that stage. So we send that over to a cloud run, a brand new cloud run endpoint. We could do some acceptance testing on that, make sure that it was doing what we were expecting it to do. If we're happy enough with that model, then it's a super quick release. So we just go onto GitHub, do a release, and then that image gets deployed to our production cloud run endpoint. So that's it from 30,000 feet from end to end. And I think it'll be super interesting for Alexey to kind of talk about, like, how he automated that, but that's it from a high level.
Yes, Alexey, please tell us.
Tell you about the kind of the GitHub flow, you mean?
Yeah, how you automated it.
So I'm not sure how much you guys are familiar with this thing on GitHub, this feature, GitHub Actions. But I'll give you a super brief overview. This is a feature that allows you to configure arbitrary sets of activities associated with your repository and executed by GitHub servers mainly. You can also run them on your own servers and triggered by GitHub, but most people do it on their own GitHub servers. So associated with your repository and associated with some events such as commits, releases, tags, merges, pull requests, whatever. Whatever happens on GitHub can trigger a GitHub action. And there is a special language. You use YAML to describe how what steps your action comprises of, and you can have as many actions as you want in a single repository. So my idea was to use this functionality to train model and to prepare all this the containers and the registry and so on every time. Every time there is a commit to the master branch. So the idea was that once you commit to master branch, it is we assume you're happy with your current state of the data and the model itself, all the parameters, and the action picks up from here. It takes your code, spins up a Docker container on GitHub server, which orchestrates other parts of our pipeline. That is, it builds a Docker image, it pushes it to the cloud registry, it connects. Actually, it starts Google Cloud GCP machine with the GPU. No, it didn't have a GPU. Never mind. So it spins off a Google virtual machine where we run MLFlow training, and when it's done, it shuts the machine down in order to only have it on when it's actually needed. And when it afterwards, as John said, it builds another Docker container with Torchserve, pushes it, and deploys it to Google Cloud Run. Again, it just the action itself issues commands against your Google GCP account. It uses gcloud, compute instance start, blah, 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 blah. Then it does execute this command to this compute instance, stop this. Then it does sort of like gcloud deploy create in order to create Cloud Run deployment. And then it just cleans up after itself.
That's amazing. Yeah, really well done with GitHub Actions. I know it's a super powerful tool and a ton of people love it. So it seems like you were able to figure out the best way to take advantage of it. And now I'm wondering, I want to get into the question that I've been wanting to ask for the last 20 minutes, which is, what were some parts you didn't like? What did you not like about MLFlow? And what did you not like about Pytorch or Torchserve? Or, I mean, mainly, what were the things that you weren't so excited about, or they caused headaches with respect to the tooling, not with respect to the way that we structured the labs? We can get into that in a little bit, but what were some things that were causing you all headaches? And I'll leave it open to anyone. So whoever wants to talk about this, just unmute yourself and let us know.
I think that I can start. When we first thought about what we should do, and we draw things there, we start thinking that we should do some small thing, but right after that we started to think bigger. I think I can say that. So I sometimes I wonder that we could build a whole pipeline building and deploying main ML components, and this in parallel. And that's when I started to think that maybe MLFlow should improve, because I think that John put there really nice in the presentation, and we right there in our wiki. But I think that MLFlow is pretty cool to experimentation phase. It's really nice there when I don't know if I can say that, but when a cowboy coder, you know that, John? When a cowboy coder, when a cowboy ML engineer start doing things by lonely. I mean, he start doing things, creating models, experimenting. It's very important for a machine learning data scientist. I mean, a data scientist should do that a lot. And MLFlow, it fits really well in that activity, in this kind of activity. But when we think about, I mean, scale things, many pipelines, building things, deploying things, when we think about containerizing things, I guess that I started to think, I started to decide that we should be using another kind of product, one more fit to be used with Kubernetes, for instance, something like that. When I was designing, I also went there into MLFlow repository to check out to see how contributors to developers of MLFlow, what they think about this kind of thing, about using MLFlow in Kubernetes or in cloud environments, how we should design that. And I think that's something that maybe MLFlow team, MLFlow contributors should look like if they want to build bigger things. If you know what I mean.
So it was like, for a smaller use case, for like you're talking about this cowboy coder, it's good enough. It's like for a pet project, yeah, it works well. But when you want to start looking at some huge scale, or when you want to start adding a little bit more on top of it, it wasn't doing the trick.
That's it.
Yeah.
I think it's at the same time though. I think it still fits into that. You're just going to need to add more components. You're going to need to add a Kubeflow or add an Airflow server or add in. You're going to have to add in all these extra parts. But I think it still fit into our architecture. It's not going to do the full bells and whistles for you, but
so you see it coming and being something that is like, it's much less of an integral part and just another Lego building block that is part of the whole thing.
Yes, but what I'd be unfamiliar with, and it's something that I'd like to see, like maybe in future engineering labs or something, is like, let's say you went the Kubeflow route to doing all this orchestration that we did through GitHub Actions. Let's say you went that full Kubernetes. Is there a Kubeflow model registry and tracking setup that's as good as MLFlow is? Because MLFlow is excellent at the tracking, and it's a good model registry. So like, do you stick with MLFlow for that little Lego brick and then use the best in class like automation pipeline and monitoring setup, or is it better to use a holistic setup that works well together?
Yeah, and that's something that people grapple with. That question comes up all the time, right? Like, should we just go, and really, I guess it's the use case and what you're willing to sacrifice, what you're willing to say, well, I guess we don't need the best in class we don't need to bring this whole metric tracking or MLFlow for this specific use case, or yeah, we do. And we want to use it. We want to figure out how it plugs in with Kubeflow or another tool. like you were talking about too, like maybe you use airflow with it or something along those lines. I think that's fascinating how you saw specifically, okay, MLFlow reaches this point. This is what it covers. And this is how far we get with it, but you can't really push it too much further. You get what you get, and then if you want more, you're going to have to add a new tool, and they're not trying to go out of the box. I mean, one thing that I'm not familiar with, but I think it's also worth mentioning is MLFlow, right? It's the open source version, but really the people behind MLFlow are Databricks. So who knows? I imagine what you were looking for, Michel, probably comes with Databricks and a nice hefty price tag too. So that's fascinating. I mean, was there anything else that turned out to be a bit of a hassle from Varuna or Alexey? Did you all have trouble with anything, whether it's with Pytorch or MLFlow?
Well, I would say that I've had spent quite a bit of time on trying to MLFlow deployment with Torchserve work in a Docker container, and the issue by itself was completely unrelated to MLFlow or Torchserve, but I run this command MLFlow deployments create like dozens of times per day, and I found it very not very informative. You create a deployment and it doesn't print you much. You're not sure whether it's working or not. If it's if it downloads a model from a remote repository, it just hangs for a while, and I found this not very user friendly. Maybe dealing with errors, maybe error reporting wasn't the best in class either. It was okay, it was fine, but not way not perfect. I would say this.
Yeah.
Overall, MLFlow as a tool, as a web UI tool, as the library and stuff like that, it's very good. And I think, in my opinion, it's as you guys already said, it's a Lego brick which fits into a wider set of tools. It's not a super tool for everything.
Yeah,
I would say.
Yeah, it's definitely not end to end, but it is good for certain use cases.
Right.
So, well, and along that, like, I kind of want to dive into and dig into what you're talking about. Like, what was the problem there that you were encountering when you were trying to use Torchserve?
So it was actually, as I said, it was completely unrelated to. It was a little bit related to what we were doing. The thing is that we were storing a model from. As we discussed before, we would train a model and store it in MLFlow registry. And then when we want to serve it for inference, we would try to get it from the registry, deserialize, and execute. And we had some very cryptic error messages when we were deserializing. And we've spent, I don't know, 2 or 3 weeks, John and Michel, maybe Varuna, all were looking into the issue. And eventually John found out that we were using different Python versions. It was something like Python 3.7 when we train and 3.8 when we serve, or vice versa. But it was completely non-obvious. And sometimes, because we didn't have a dedicated base Docker environment that would guarantee that all the dependencies use the same versions, we had this issue, which, as I said, took a lot of time and a lot of effort to troubleshoot.
How would you have changed that so that you could have managed the dependencies better? Is it just what you're talking about, having this base of Docker images, or what are you thinking would have been better in that case?
Well, yeah, I think that when you work on a project with different environments, in our case, that was a serving environment, a training environment, it's crucial to make sure they are very much aligned to each other. So making sure there is a baseline and the dependencies, all the libraries, tools, command line, including command line stuff, has more or less hard-coded versions, especially in the ML world when things change so rapidly. APIs change, behaviors change, right? So it's very important to have fixed versions, being very specific and being very careful when you propagate these changes across multiple environments.
Yeah, that is a huge one. And I know that's also a question that comes up a lot, not only within MLFlow, but dealing with dependencies. If you start to link up MLFlow with other tools, how do you deal with the dependencies within all of these different steps, right? So it gets very confusing and very complicated quickly. Now, Varuna, you're the only one who hasn't said what has been a pain in the ass. So give it to us, man. What did you think was difficult about it?
The problems I had are very similar to Alexey. Like when I first ran, there were a couple of errors on Torchserve. They were a little hard to understand. And to add to what Alexey said, like the problem we had there was partly because the models were pickled, I assume. So which would be the case after MLFlow upgrades the API to let it save models using a state dictionary, like the usual PyTorch way of doing things. So a small subtle package difference wouldn't really matter. Because in certain cases, it might not be possible to keep all the environments same. Like a training environment might actually be different from the production environment. Like it might need different pip packages that the production environment doesn't need, and it'll have like other codes that's specific for training. So once the model saving part is resolved on MLFlow side, this wouldn't be that much of a problem. But the problem I had was like Torchserve was giving out errors. Like, yeah, it wasn't. It was throwing errors, and both them and MLFlow, they could have done some more checks at the start, sort of, to say like, okay, this is gonna happen until it wait till the model is actually executed to show those errors.
So the integration,
sanity checks sort of stuff.
Yeah, makes complete sense. The integration is there, but it's not so coherent and it's not so harmonious.
I guess like because this case probably like many more people would have come across the same thing, so they could just do some sort of like a check to say, okay, this is happening as soon as you load up a new model, sort of.
Yeah, we're giving them free user feedback right now. They should sponsor the next lab. These guys. But I think it's really cool to hear all of these different pain points that you stumbled on. If there's anything else, feel free to jump in about it. But I am wondering now, like, as far as the whole experience went from the inception till the end, you guys stuck with it. It's a lot to say about more than, you were only one of two teams that stuck with it. And from the inception until the finish, how did this whole experience go? Like, did you learn what you feel like you wanted to learn? Or do you feel like there could have been more? Do you want to use it as the first step, and then next one, like John was saying, now you'll put it to the test with Kubeflow? Or I personally would just love to hear the feedback on how the lab went, and I think that is how we can finish it. So I see Michel to my right. Maybe you can start us off, and then we can just go down the line.
Okay, I can say that it was fantastic. I mean, the whole idea. We had many challenges, for guys, different cultures, different languages, working on their spare time, and an open set of requirements. We didn't have strict requirements. I mean, just use MLFlow, Pytorch, and that's it. Go. And it was nice, really nice to me. I mean, I learned a lot. I think that MLFlow really nailed it. I'm quite impressed with MLFlow because it can help a lot the data scientist guys, and I think that you know, engineering labs, it's an initiative that surely should go on. I would like to be part of it in the future. I mean, the next labs. I really don't know what I can say more because I'm going to spend the whole time here saying compliments. Inardo did a really great job there, and I think that's it. That's it. I mean, I think all went well. Of course, there are things we got to improve. It's okay. Okay, it's okay. I mean, it's okay with that. It's just the first iteration. Okay,
Exactly.
we have room to improve there. But overall, even though the governance part, I mean, is there something I for good or worse, I think there is something we gotta do as team, and in my humble opinion, we did it.
Nice. Excellent. Varuna, how about yourself?
Yeah, I learned a lot, like all this Docker stuff and the cloud stuff were kind of new to me. So I learned a lot there and I'm still learning. Like I actually need to go through the repo like a couple of times more to get into the details. Like for most part of this project, I was just an observer, like looking at these guys' work. I had seen them like from some time to time, like GitHub Actions and all that, but I had never used them. But now this gives me like a tangible thing that I could look at any point of time and learn from it. Like it's a lot better than, like I would have learned a lot slower if I were just reading up tutorials or something. So this helped a lot.
Oh, that's
And how
awesome.
different people think of approaching these kind of problems and so on. Like I wouldn't, like this was probably the way I would have gone if I were to do it, but the end result here is much better. So if I were to do something again, this is how I would think about it.
Now you know.
Yeah.
That's brilliant. All right, John, I got you up next. How about your experience?
I think we were lucky in the team we had, to be honest. Like apart from a technical side of things, I think the team we worked really well together. I think everyone was really dedicated to doing it on their spare time, dedicated to learning it and working really well together. Like we worked, like communicated super well in Zoom, super well in Slack, super well on GitHub. Like the reviews were better than I've seen on most of my job stuff. Like it was excellent. Like so communication across the board like was just amazing. So I think that's why we were so successful, is that we were able to do that. And then on a technical point of view, I love the lab because like I've been trying to get a sense of like the MLOps kind of like whole world, and it's just massive. And you keep seeing these diagrams and people go like, you know, here's all the tools, and you just see like all of these logos all over the place. I'm like, I have no idea. I have nothing tangible to grab onto there. So at least now from doing this lab, I can go like, okay, I understand the registry part and I understand like the automation part. And I kind of have a good grasp of that now. And now I can go from there and learn the monitoring or learn the other parts. So like, I feel like I have a bit of an anchor into the world of MLOps now from having done this lab.
Oh, that's brilliant. Yeah, like you bit off a little piece of the cookie and now you can bite off a little more.
Right.
I like it. All right, Alexey, bring us home, man.
So at first, I concur with John in a sense that I also got this hands-on experience and understand of the whole pipeline, of the tools of how people work. Or like before, I had no idea whether researchers what they tune via config files, what they do from command line, where they use web tools. I know all these things exist, but how much of each component is involved in real day-to-day work was a mystery to me. So now I more or less see it at least on a simple test project. And yes, I definitely achieved my goal of getting this experience. I also really enjoyed how like a group of 4 people formed up a team and how we managed to reach the end of the project step by step by iterations, essentially with all the good engineering practices. And what we get at the end is not just a project like a result of a hackathon, but I feel like it's a very well engineered thing. Maybe, well, definitely not 100% complete and production ready, but we never cut corners, which I think is very rare in real life. A lot of engineers do this all the time, and we didn't, and I think that's really cool. And we've got where to go. We've got this amazing Terraform thing that Michel wrote. We can go with different improvements on other sides, different models. We can work with the feedback loop, the Flask app that John implemented. So this project, I like that we're at a checkpoint, and there are several ways we can take on.
Oh man, that's great. What's this Terraform piece that Michel wrote?
Well, when I did that, I was thinking about allowing people that go there in the repo, try to reproduce the things we did, building a new infrastructure. Sometimes when you start something like that, you start with one thing in mind, and you start changing your infrastructure, changing configuration. And with Terraform in Ansible, I tried to create a baseline there, so everyone that tries to go there and try to reproduce what we did may have a good startup. I mean, to create the infrastructure, to configure everything, to reproduce what we did.
Oh, that is amazing. I had no idea you guys did that. So for anyone that wants to go and get the foundation, they can get it on the GitHub page, and there's the Terraform that they can take.
Yes, there in the source code, there is a part there that you can find some Terraform code, Ansible code as well, and you can build your infrastructure. Actually, you can build your infrastructure in GCP, because that's the cloud we were using for our tests.
Mm-hmm.
And you can build it there and reproduce what we did. Okay.
Amazing. Wow. That is news to me. That's a surprise, and that just makes it all even better. Amazing, Michel. And team 1 right now, you guys are incredible, and I just want to echo the sentiment of you all. It is incredible that 4 people that have never known each other before got together and created this. And I think I remember John saying in Slack, like, oh, I've never been that proud of my GitHub, or I haven't had something on my GitHub that I was proud of for a while, but now I am. So you all did an absolutely brilliant job. I want to thank you for doing it, because I know it took a lot of work, and I hope that you're able to use this and build on it. And then we will put you together for the next engineering lab, and we'll bite off another piece of that cookie, see what we can get to, see where we take it next. Maybe it's the monitoring piece, maybe it's the pipelines piece. But I think that the whole idea here, you guys you nailed it in my mind. So great job. Congrats. And anyone that wants to talk to you about it, you're all in the Engineering Labs channel on Slack. And so, yeah, people can probably go and pick your brain. I imagine you're open to sharing, considering you're sharing right now with all of us. And that's it for today's coffee session. I really thank you all for joining me and explaining everything. Cheers, fellas.